All right, so we are going to do law of cosine. Now, last class we learned how to apply law of sine to triangles that are what? Someone give me an example of a triangle that we would apply law of sine to. Yeah, but like, what parts would they need to give us in order for us to apply law of sine? Like, is it? There we are. Not side angle side though. Yes, we can apply SSA, but we know this is the maybe ambiguous piece, right? What else could we apply law of AAS? Yeah, AAS, and I think that there was one more. Did I see it here? I don't think I've seen it yet. One more. When they give us, oh boy, this is important. Yeah, angle sin angle. You need to know this because this will tell you, well, I mean, you could always try to apply law of sines and sometimes it would work because basically you're not given one of these three triangles. You need to have either ASA, AAS, or SSA to apply law of sine. Today, if they instead give us side angle side or side side side, you can instead apply law of cosine. If we tried to apply law of sines to these two, it would not work. It would not work. We couldn't do it. Now, side angle side is when you have an angle and a side and a side. You can use law of cosine. Notice on this triangle here, I can't possibly apply law of sine because I don't have a side across from an angle. And remember, law of sines is the sine of an angle over the side across from it. So because I'm not given those things, I can't apply law of sine here. Instead, we use law of cosine. Now, what the law of cosine states is, let me make this angle B and angle C. What the law of cosine states is the side across from the angle that you're given. If I'm trying to find that side length, all I have to do is take the other two side lengths it gives us. We'll call these B and C. You take them and you square them, add it together, and then you subtract 2 times those same side lengths again times the cosine of the angle they gave you. These other two formulas here are the exact same thing, just with a different arrangement of letters. All that you need to remember is if you're trying to find a side length, you add the other two side lengths together squared minus 2 times those side lengths multiplied together times cosine of the angle they gave you. Now, there is a proof for this. Someone way back when derived this. And they created these formulas. All formulas have been created one way or another. They created these formulas using the distance formula, just like the Pythagorean theorem was created using the distance formula. Now, I'm not going to do this proof with you, not because I don't think it's worthwhile to see, but because um, part of this proof includes a trig identity, which we have not touched trig identities at all this year. So you wouldn't even understand part of this proof. It's a hard proof to begin with, and it has a trig identity in it, which you haven't learned. So I am not going to do this proof yet because you wouldn't even understand it. When we do learn trig identities later in the year, maybe I'll come back and we will prove um, the law of cosines. All right, so now we're just going to look at a couple of examples. This first example says given triangle ABC, which it doesn't really matter where I put these as long as the side lengths um, are in relation to the angles. So I have side length A is 11, so across from angle A, is 11. Across from angle B, side length is 5. And angle C is 20. So here, notice this is a side angle side, meaning I have to apply law of cosines here. I can't, I wouldn't use straight here because there's no right angle, right? And I can't use law of sines because there is no side across from an angle. I have to use law of cosines. Now, what solve for side C? What this means is I'm going to have, now write the formula up top. Normally, you don't need to write the formula as long as you input the variables correctly, but I'll write it this first time. So this side length C is going to be equal to a squared plus b squared minus 2 times a times b times cosine of C. So this is going to be C squared is equal to our a is 11, our b is 5, our a is again 11, and our b again is 5, and our angle C is 20. So I will show you what each part of this is simplified. However, you could just plug this entire, actually maybe, I might just plug this whole thing in my calculator. So here I'm going to do, get out of the, why is this so big? Shrink. Nope. Okay. So I'm going to do 11 squared plus 5 squared minus 2 times 11 times 5 times cosine of 20. The reason that I'm okay with just showing you plugging this whole thing in the calculator is because as soon as you see that there's trig in a problem, you know that you will never get a non-calculator problem that has trig like this. So that's why I'm okay with plugging it in because, yeah, way back when people had to memorize trig tables and know these values, that hasn't been done in many, many years. So it's fine just to plug it all in the calculator, except if there's something wrong. Oh, you know what? My gosh, rookie mistake over here. I can't believe I didn't put it in degree mode. I would have gotten that problem wrong. Now, is this my final answer? What is wrong with it? Ah, this is still c squared. So not square it, but I have to do, yes, square root both sides. Then you actually get c is equal to 6.529. Now, notice I didn't put plus or minus because our side length's negative. No, no. So I did square root, but I'm not going to have a negative side length on a triangle unless I'm on a coordinate plane. Yes, yeah. Probably means that you did something wrong. No, there. Stop right there. 2 times 11 times 5 is multiplied times cosine of 20. Yeah, yeah. You need to deal with multiplication first, always. So you can't just combine 11 squared plus 5 squared minus 2 times 11 times 5 because 2 times 11 times 5 is multiply times cosine of 20. You have to multiply that first. That's why. Yeah. Okay. So thumbs up if you could do this on your own. Thumbs down if you would like another example. Okay. All right. So I will do one more here, and I'll do it. I don't have to, like I said, normally if I was doing this on my own, would I write out the equation? No, I would just input the values. Now there isn't a triangle drawn, so I'm going to quickly draw one. And I have this, it looks like my values are A, B, and C again. So then it says angle A is 55. It says B, which is across from angle B, is 12. Whoops, that looks like it's only two, doesn't it? And C across from side C is 7. So again, I'm given a side, angle, side, meaning the only way that I can solve this is by using law of sine. Oh my gosh, law of cosine. Because if I tried to apply law of sines, I would realize, okay, I don't have a side across from the only angle. I have to use law of cosine. So I'm trying to solve for, ooh, eventually angle C. But I know that in order to find C, I first need to know what this side length over here is. I need to know what the angle across from, or I need to know what the side across from angle 55 is. So that's what I'm going to be solving for. A squared is equal to the other two sides squared added together minus 2 times those sides multiplied together times cosine of 55. And then I just take out my calculator. So I just take all those values, plug them into the equation, and I get 9.831. Uh, but we're trying to solve for angle C. So who knows from here, what would I have to do to solve for angle C? Now that I know that this is 9.831. Yeah, well, science, wonderful. So here I'm going to do sine of the angle across from the side I just found over the side I just found. 9.831 is that equal to, and I'm trying to solve for C, angle C. So that means that the side length I need underneath is 7 over sine of C. Then I pull out my calculator and I do 7 times sine 55 divided by 9.8. Oh, what am I doing? I'm so bad. I'm doing what I yell at people to do all the time. Gotta pull down. But that is what sine of C is equal to. So I'll write it down. 0.58 is what sine of C is equal to. How do we get C by itself? Right. You do the inverse sine. You have to inverse both sides. Well, these cancel. So the measure of angle C is going to be equal to the inverse of what we just found. 35.68. Is that right? Huh, that's not what I have written. Oh, it's because I saw for B first. Okay, 35.68 degrees, and I'm done. Any questions?